Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, variant 2, February March 2019. Let's get started. Amol and Priya deliver 645 parcels in the ratio. Amol is to Priya equals 11:4. Calculate the number of parcels Amol delivers. To get the number of parcels Amol delivers, we divide the ratio share for Amol, which is 11, by the total ratio, which is 11 plus 4, and multiply by 645. This gives us 473. Amol drives his truck at an average speed of 50 kilometers per hour. He leaves at 7 o'clock and arrives at 11:15. Calculate the distance he drives. First, we need to find the time duration of his journey. To get this, we subtract his departure time, which is 7 o'clock, from his arrival time, which is 11:15. Under the minute column, 15 minus 0 is 15. Under the hour column, 11 minus 7 is 4. So now we know the time duration is 4 hours 15 minutes. We can use this formula to get the distance he travels. When we make the distance be the subject, this is what we get. The speed v is 50 kilometers per hour, and we found the time duration to be 415/60 hours. When we type this into the calculator, we get 212.5 kilometers. Priya drives her van a distance of 54 kilometers. She leaves at 10:55 and arrives at 12:38. Calculate her average speed. First, we need to find the time duration of her journey. To get this, we subtract her departure time, which is 10:55, from her arrival time, which is 12:38. Under the minute column, we can't subtract 55 from 38, so we get 1 hour from the hour column, which becomes 60 minutes under the minute column. So we have 98 minutes. 98 minus 55 is 43. Under the hour column, 11 minus 10 is 1. So now we know the time duration is 1 hour 43 minutes. We can use this formula to get her average speed. The distance d she travels is 54 kilometers. We found the time duration to be 143/60 hours. When we type this into the calculator, we get 31.5 kilometers per hour, rounded to 3 significant figures. Priya has 50 identical parcels. Each parcel has a mass of 17 kilograms, correct to the nearest kilogram. Find the upper bound for the total mass of the 50 parcels. To correct the mass to the nearest kilogram, we have 17 kilograms. Then we bring in plus and minus 1 kilogram. Then we divide 1 kilogram by 2. To get the upper bound of the mass, we ignore the minus, so we have 17 plus 1/2 kilograms. We want to find the upper bound for the 50 parcels, so we multiply this by 50. This gives us 875 kilograms. 67 of the 645 parcels are damaged on the journey. Calculate the percentage of parcels that are damaged. To get this percentage, we divide the number of damaged parcels, which is 67, by the total number of parcels, which is 645, and multiply by 100%. This gives us 10.4%, rounded to 3 significant figures. 29 parcels each have a value of $68. By writing each of these numbers correct to one significant figure, find an estimate for the total value of these 29 parcels. Before we find the total value of the parcels, let's round the numbers to one significant figure. For 29, the first significant figure is 2. The number after 2, which is 9, is greater than 5. So we add 1 to 2, giving us 3. The number after 2 becomes 0. So 29 becomes 30, rounded to one significant figure. For 68, the first significant figure is 6. The number after 6, which is 8, is greater than 5. So we add 1 to 6, giving us 7. The number after 6 becomes 0. So 68 becomes 70, rounded to one significant figure. So the total value of the parcels would be 30 times $70, which is equal to $2,100. Without doing any calculation, complete this statement. The actual total value of these 29 parcels is less than the answer to part FI because blank. This is because both numbers used in the estimation in part FI are rounded up. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangle A and triangle B, they have the same size but their orientation is different, which means the transformation is either a reflection or a rotation. In this case, we see that triangle B is a mirror image of triangle A in the line x equals 1.5. And so the full description for the transformation would be reflection in the line x equals 1.5. Describe fully the single transformation that maps triangle A onto triangle C. When we look at triangles A and C, we can tell straight away that this is a rotation 90 degrees in the anti-clockwise direction. So now we need to identify the center of rotation. For a 90-degree rotation, the way to determine the center of rotation is this. We draw a line to connect at least two corresponding points on both triangles A and C. Then we need to draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation. In this case, the point has coordinates 0, -1, and so the full description for the transformation would be rotation 90 degrees anti-clockwise about the center 0, -1. On the grid, draw the image of triangle A after an enlargement scale factor -½ center 30. First, we need to mark the center of enlargement, which is 30. Then we need to move each vertex on triangle A such that we are able to reproduce the enlarged image of the triangle. Let's pick point B. To move from the center of enlargement to point B, we move 4 units to the left and 2 units upwards. To pin the new position of point B, since the scale factor is -½ we need to move half the distance we moved initially and in the opposite direction. This means we are going to move 2 units to the right and 1 unit downwards. After repeating the same process for all the other points, we are now able to map out the enlarged image of the triangle. On the grid, draw the image of triangle A after a translation by the vector -3, 1. For this translation, the translation vector dictates that we move each of the vertices of triangle A 3 units to the left and 1 unit upwards. On the diagram, the movement for point C has been shown. After repeating the same process for all the other points as well, we are able to map out the translated image of triangle A. On the grid, draw the image of triangle A after the transformation that is represented by the matrix 0, 1, 1, 0. The given matrix represents a reflection in the line y equals x. On the grid, we draw the line y equals x. From here, we need to reflect the vertices of triangle A in this line. So for point B on the triangle, since we move 3 units to the right to touch the line of reflection, we also need to move 3 units downwards from the line of reflection to pin the new position of point B. After repeating the same process for all the other points as well, we are able to map out the reflected image of triangle A. Sushila, Ravi and Talika each have a bag of balls. Each of the bags contains 10 red balls and 8 blue balls. Sushila takes one ball at random from her bag. Find the probability that she takes a red ball. This probability is equal to the number of red balls in her bag, which is 10, divided by the total number of balls, which is 10 plus 8. This gives us 5/9. Ravi takes 2 balls at random from his bag without replacement. Find the probability that one ball is red and one ball is blue. The probability that the first ball is red is equal to the number of red balls in his bag, which is 10, divided by the total number of balls, which is 18. After he picks the red ball, the number of balls in the bag reduced by 1. So the probability that the second ball he picks is blue is equal to the number of blue balls, which is 8, divided by the total number of balls, which is 17. The order in which these 2 balls are picked may be reversed, making the total number of possible orders in which the balls can be picked to be 2. So we multiply this probability by 2. When we type this into the calculator, we get 80/153. Talika takes 3 balls at random from her bag without replacement. Calculate the probability that the 3 balls are the same color. There are 2 scenarios in this case. She either picks 3 red balls or 3 blue balls. The probability that the first ball she picks from her bag is red is 10/18. Without replacement, the probability that the second ball she picks is red is 9/17. Without replacement, the probability that the third ball she picks from her bag is also red is 8/16. The probability that the first ball she picks from her bag is blue is 8/18. Without replacement, the probability that the second ball she picks is blue is 7/17. Without replacement, the probability that the third ball she picks from her bag is also blue is 6/16. When we type this into the calculator, we get 11/51. The diagram shows an incomplete scale drawing of a marketplace ABCD, where D is on CX. The scale is 1 cm, represents 5 meters. D lies on CX such that angle DAB equals 75 degrees. On the diagram, draw the line AD and mark the position of D. Using a protractor, we measure and mark an angle of 75 degrees from point A. When we are done, we draw a line from point A through the 75-degree mark. The point where this line cuts CX is point D. Find the actual length of the side BC of the marketplace. On the diagram, when we measure the length of BC, we get 9.5 centimeters. Using the scale conversion of 1 centimeter is to 5 meters, we can find the actual distance of BC, which is what we are calling x. When we cross multiply and make x the subject, this is what we get, which is equal to 47.5 meters. In this part, use a ruler and compasses only. Street sellers are allowed in the part of the marketplace that is more than 35 meters from A and nearer to C than to B and nearer to CD than to BC. On the diagram, construct and shade the region where the street sellers are allowed. Using the scale conversion, 35 meters translates to 7 centimeters on the map. To be able to indicate this region, we need to draw an arc or circle with a radius of 7 centimeters from point A. So on the diagram, we first need to measure our compass to have a width of 7 centimeters, stand at point A and construct an arc. To be able to indicate this region, we need to draw the perpendicular bisector of line BC. So on the diagram, we stand at point B, open our compass to a width that is more than half of BC, and construct an arc above and below the line. Using the same compass width, we stand at point C and construct another set of arcs above and below the line. When we are done, we draw a straight line passing through the intersection points of the arcs. To be able to indicate this region, we need to draw the angle bisector of angle BCD. Using a pair of compasses, we stand at point C and describe an angle for angle BCD. Then standing at this point, we open the compass to a wider width and construct an arc. Using the same compass width, we stand at this point and construct another arc. When we are done, we draw a straight line from point C that passes through the intersection points of the arcs. After drawing these boundaries, we can now shade the region that is 7 cm from A, nearer to C than to B, and nearer to CD than to BC. Write the scale of the drawing in the form 1:n. We've been given the scale of the drawing to be 1 cm to 5 meters. To convert 5 meters to centimeters, we multiply 5 by 100. 5 times 100 is 500, so we have 1:500. The table shows some values for y equals 3/10x cubed minus 2x. For x is greater than and equal to -3 and less than and equal to 3. Complete the table. When we plug in x equals -3 into the equation, we get y equals -2.1. For x equals -2, we get y equals 1.6. For x equals 1, we get y equals -1.7. And for x equals 3, we get y equals 2.1. On the grid, draw the graph of y equals 3/10x cubed minus 2x. For x is greater than and equal to -3 and less than and equal to 3. On the grid, we plot all the points in the table and connect the points with a smooth line. On the grid opposites, draw a suitable straight line to solve the equation 3/10x cubed minus 2x equals half of 1 minus x. For x is greater than and equal to -3 and less than and equal to 3. In other words, we are to find the x-coordinate of the intersection points between the graph of y equals 3/10x cubed minus 2x and the line y equals half of 1 minus x. To draw the line y equals half of 1 minus x, we need at least 2 points on this line. When we plug in x equals 0 into the equation, we get y equals half. And when we plug in x equals 1 into the equation, we get y equals 0. On the grid, we plot the points 0, 1/2 and 1, 0 and connect these points with a straight line. When we are done, we see that the x-coordinates of the intersection points are -2.05, -0.45 and 2.35. For x is greater than and equal to -3 and less than and equal to 3, the equation 3/10x cubed minus 2x equals 1 has n solutions. Write down the value of n. First, we draw the line y equals 1 on the grid. We see that this line intersects the graph at 3 points. This means the given equation has 3 solutions, so n equals 3. The diagram shows a company logo made from a rectangle and a major sector of a circle. The circle has center O and radius OA. OA equals OD equals 0.5 centimeters and AB equals 1.5 centimeters. E is a point on OC such that OE equals 0.25 centimeters and angle OED equals 90 degrees. Calculate the perimeter of the logo. The perimeter of the logo is the distance around the shape of the logo. So that would be CB plus OC plus AB plus OD plus arc AD. CB is 0.5 centimeters, OC is 1.5 centimeters, AB is 1.5 centimeters, OD is 0.5 centimeters. To get the distance around arc AD, we use the formula theta over 360 degrees times 2 pi r, where the radius r is 0.5 centimeters. Theta, which is angle AOD, has not been given, so we need to find that. Angles formed at a point add up to 360 degrees. So to get angle AOD, we subtract the sum of 90 degrees and alpha from 360 degrees. We can get alpha by applying SOHCAHTOA to the right-angled triangle ODE. This gives us cos alpha equals 0.25 centimeters over 0.5 centimeters. When we make alpha the subject, this is what we have, which is equal to 60 degrees. So angle AOD is equal to 360 degrees minus 90 degrees plus 60 degrees, which is equal to 210 degrees. So now, when we type this into the calculator, we get 5.83 centimeters rounded to 3 significant figures. Calculate the area of the logo. The area of the logo is equal to the area of the rectangle plus the area of the sector. We get the area of the rectangle using length times width, where the length is 1.5 centimeters and the width is 0.5 centimeters. We get the area of the sector using theta over 360 degrees times pi r squared, where theta is 210 degrees and the radius r is 1.5 centimeters. When we type this into the calculator, we get 1.21 centimeters squared rounded to 3 significant figures. A mathematically similar logo is drawn. The area of this logo is 77.44 centimeters squared. Calculate the radius of the major sector in this logo. For similar shapes, we know that the ratio of their areas must be equal to the square of the ratio of their corresponding sides. When we make big R the subject, this is what we get. When we type this into the calculator, we get 4 centimeters. A gold model is made. This model is a prism with a cross-section of area 77.44 centimeters squared. This gold model is 15 millimeters thick. 1 cubic centimeter of gold has a mass of 19 grams. Calculate the mass of the gold model in kilograms. First, we need to find the volume of the prism. The volume of the prism is equal to its cross-sectional area, which is 77.44 centimeters squared times its length, or in this case, its thickness, which is 15 millimeters. We convert 15 millimeters to centimeters by multiplying 15 by 10 raised to the power negative 1. This gives us 116.16 centimeters cubed. If 1 centimeter cubed of the golden prism is 19 grams, then what will be the mass of the prism, which has a volume of 116.16 centimeters cubed? This is what we are calling x. When we cross multiply and make x the subject, this is what we get. We convert 19 grams to kilograms by dividing 19 by 1000. When we type this into the calculator, we get 2.20704 kilograms. 20 students each record the mass, p grams, of their pencil case. The table shows the results. Calculate an estimate of the mean mass. The mean is equal to sigma f of x, which represents the total mass of all the pencil cases, divided by sigma f, which is the total number of pencil cases. Before getting sigma f of x, we need to get a midpoint mass for each of the given mass intervals. So for the first interval, the midpoint mass is 0 plus 50 divided by 2, which is 25. Then we have 50 plus 100 divided by 2, which is 75. 100 plus 125 divided by 2, which is 112.5. 125 plus 150 divided by 2, which is 137.5. 150 plus 200 divided by 2, which is 175. So for sigma f of x, we have 25 times 2 plus 75 times 5 plus 112.5 times 4 plus 137.5 times 6 plus 175 times 3 grams divided by 20. When we type this into the calculator, we get 111.25 grams. Use the frequency table above to complete the cumulative frequency table. For P is less than and equal to 50, the cumulative frequency is 2. For P is less than and equal to 100, the cumulative frequency is 2 plus 5, which is 7. For P is less than and equal to 125, the cumulative frequency is 7 plus 4, which is 11. For P is less than and equal to 150, the cumulative frequency is 11 plus 6, which is 17. A student is chosen at random. Find the probability that this student has a pencil case with a mass greater than 150 grams. This probability is equal to the number of students with a pencil case that has a mass greater than 150 grams, which is 3, divided by the total number of students, which is 20. Some students each record the mass m kilograms of their school bag. Adil wants to draw a histogram to show this information. Complete the table below. The frequency density gives us the height of the intervals on a histogram. In this case, the frequency density and the height drawn on the histogram have different values. This simply means the height is equal to the frequency density times a certain scale factor, which we are calling k. We can use any of these two sets of information to get k. We are going with this set. In this case, the height is 1.6 centimeters. The frequency density is equal to the frequency, which is 32, divided by the interval width, which is 4 minus 0. When we make k the subject, we get k equals 0.2. Now that we have the value of k, we can find the frequency for the other intervals. For this interval, we have 2 equals the frequency density, which is the frequency divided by the interval width, which is 6 minus 4 times 0.2. 0.2 over 6 minus 4 is 0.1. When we divide both sides by 0.1, we get the frequency to be 20. For this interval, we have 1.2 equals the frequency density, which is the frequency divided by the interval width, which is 7 minus 6 times 0.2. 0.2 over 7 minus 6 is 0.2. When we divide both sides by 0.2, we get the frequency to be 6. The frequency table below shows information about the number of books read by some students in a reading marathon. The mean number of books read is 4.28. Find the value of x. The mean, which has been given as 4.28, is equal to the total number of books read, which is 1 times 2 plus 2 times 2 plus 3 times 16 plus 4 times 10 plus 5 times 9 plus 6 times 4 plus 7x plus 8 times 2 divided by the sum of the frequencies, which is 2 plus 2 plus 16 plus 10 plus 9 plus 4 plus x plus 2. When we type this into the calculator, we get 179. And when we type this into the calculator, we get 45. When we multiply both sides by 45 plus x, this is what we have. When we expand the brackets, 4.28 times 45 is 192.6. 4.28 times x is 4.28x. When we group like terms, we get 2.72x equals 13.6. And when we divide both sides by 2.72, we get x equals 5. Write down the mode. The mode is the number with the highest frequency. The highest frequency is 16. The number with this frequency is 3. Write down the median. The median is the middle number. To get the position of the middle number, we apply the formula half n plus 1, where n, which is the sum of the frequencies, is 50. This gives us 25.5. This means the median is between the 25th and 26th numbers. From the table, to get the numbers in these positions, we start adding the frequencies from the lowest number. So 2 plus 2 is 4. 4 plus 16 is 20. 20 plus 10 is 30. This means the numbers in the 25th and 26th positions are both 4. So the median is 4 plus 4 over 2, which is 4. Work out g of 1 over 4. To get g of 1 over 4, we replace x in g of x with 1 over 4. This gives us 8 times 1 over 4 minus 5, which is equal to -3. Work out f of 2. First, let's find f of 2. To get f of 2, we replace x in f of x with 2. This gives us 3 over 2 plus 2, which is equal to 3 over 4. So to get f of 2, we replace x in f of x with f of 2, which we found to be 3 over 4. So we have 3 over 4 plus 2, which is equal to 12 over 11. Find g of x, given your answer in its simplest form. To get g of x, we replace x in g of x with g of x, which is 8x minus 5. So we have 8 times 8x minus 5 minus 5. When we expand the brackets, 8 times 8x is 64x. 8 times -5 is -40. When we group like terms, -40 minus 5 is -45. So we have 64x minus 45. Find g inverse of x. We know g of x is 8x minus 5. In the first step, we replace g of x with x and replace x with y. When we make y the subject, this is what we get. The result we have for y is the same as g inverse of x, which means g inverse of x is also equal to x plus 5 over 8. Write g of x minus f of x as a single fraction in its simplest form. We've been given g of x as 8x minus 5 and f of x as 3 over x plus 2. To write this as a single fraction, we cross multiply, so we have 8x minus 5 times x plus 2 minus 3 times 1, which is 3, and divide by the LCM, which we get by multiplying the denominators of the two fractions. When we expand 8x minus 5 times x plus 2, we get 8x squared plus 16x minus 5x minus 10. When we group like terms, 16x minus 5x is 11x. Minus 10 minus 3 is minus 13. So we have 8x squared plus 11x minus 13 over x plus 2. Show that h of g of x equals 19 simplifies to 16x squared minus 20x plus 3 equals 0. To get h of g of x, we replace x in h of x with g of x, which is 8x minus 5. This gives us 8x minus 5 squared plus 6, which is equal to 19. When we expand 8x minus 5 squared, we get 64x squared minus 80x plus 25. When we move the terms to one side of the equation and group like terms, we get 64x squared minus 80x plus 12 equals 0. The terms have a common factor of 4. When we divide through the equation by 4, we get 16x squared minus 20x plus 3 equals 0. Use the quadratic formula to solve 16x squared minus 20x plus 3 equals 0. Show all your working and give your answers correct to 2 decimal places. When we apply the quadratic formula to the given equation, this is what we get. Negative of -20 is 20. The numbers under the square root, -20 squared minus 4 times 16 times 3 gives us 208. For the denominator, 2 times 16 is 32. For the first possible value of x, we get 1.08 rounded to 2 decimal places. And for the second possible value of x, we get 0.17 rounded to 2 decimal places. The Venn diagram shows two sets, A and B. Use set notation to complete the statements. D is a member of set A. F, G are elements in the region A intersection B. Complete the statements. The number of elements in blank equals 6. The number of elements in set B is 6. In the Venn diagram below, shade C intersection D complements. In other words, we are to shade the region that is in set C and not in set D. This region has been shaded on the Venn diagram. 50 students study at least one of the subjects, geography, mathematics, and history. 18 study only mathematics. 19 study 2 or 3 of these subjects. 23 study geography. The Venn diagram below is to be used to show this information. Show that x equals 4. We are told 19 students study 2 or 3 of the given subjects. This means when we sum up the elements in this region, they must add up to 19. So we have 3x plus 7 equals 19. When we subtract 7 from both sides, we get 3x equals 12. And when we divide both sides by 3, we get x equals 4. Complete the Venn diagram. Based on this, we know that there would be no students outside sets G, M, and H. We are told 18 students study only mathematics, so we put 18 in this region. We are told 23 students study geography. This means if we add the elements in this region, we should get 23. So to get the number of students who study only geography, this is what we have, which is equal to 8. We know there are 50 students in total, so to get the number of students who study only history, this is what we have, which is equal to 5. Use set notation to complete the statements. G union M union H complement equals blank. We are to list the elements in the region outside G union M union H. There are no elements in this region, so we have a null set. Find the number of elements in G intersection M union H. From the Venn diagram, the number of elements in this region is 15. Solve the simultaneous equations. You must show all your working. First, let's label the given equations. We will be using the elimination method. We want to eliminate y. So we multiply equation 1 by 3. This gives us 18x plus 15y equals 81, which we've labeled as equation 3. We also multiply equation 2 by 5. This gives us 25x minus 15y equals 220, which we've labeled as equation 4. Now that we have 15y in equation 3 and minus 15y in equation 4, we eliminate y by adding equation 3 to equation 4. This gives us 43x equals 301. When we divide both sides by 43, we get x equals 7. We can now plug in the value of x into any of the equations to get the value of y. If we pick equation 1, we have 6 times 7 plus 5y equals 27. 6 times 7 is 42. When we subtract 42 from both sides, this is what we have. And when we divide both sides by 5, we get y equals negative 3. Y is inversely proportional to x plus 3 squared. When x is 2, y is 8. Find y when x is 7. In mathematical terms, we write y is inversely proportional to x plus 3 squared. We can rewrite this as y is equal to a constant, which we are going to call k, times 1 over x plus 3 squared, which is k over x plus 3 squared. From here, we need to find the value of k. We can get the value of k by plugging in the values of x and y given in the question. This gives us 8 equals k over 2 plus 3 squared. 2 plus 3 squared is 25. When we multiply both sides by 25, we get k equals 200. Now that we have the value of k, when x is 7, y equals 200 over 7 plus 3 squared, which is equal to 2. Solve the inequality. 3 times x minus 2 is less than 7 times x plus 2. When we expand the brackets, 3 times x is 3x. 3 times negative 2 is negative 6. 7 times x is 7x. 7 times 2 is 14. When we group like terms, this is what we have. When we divide both sides by 4, we have negative 5 is less than x. We can rewrite this as x is greater than negative 5. The table shows the first 5 terms of sequence A and sequence B. Complete the table for the sixth term of each sequence. For sequence A, to get the sixth term, we add 22 to 55. This gives us 77. For sequence B, to get the sixth term, we multiply 81 by 3. This gives us 243. Find the nth term of sequence A. Sequence A is a quadratic sequence, so we can use this formula to get the nth term. To get A, we equate 2a to the constant difference, which is 4. When we divide both sides by 2, we get a equals 2. To get B, we equate 3a plus b to the first term of the first difference, which is 6. We found a to be 2. When we make b the subject, we get b equals 0. To get c, we equate a plus b plus c to the first term of the sequence, which is 7. We found a to be 2 and b to be 0. When we make c the subject, we get c equals 5. When we plug in the values of a, b, and c into the nth term formula, we get 2n squared plus 5. Find the nth term of sequence B. Sequence B is a geometric sequence, so we can use this formula to get the nth term. A1, which is the first term, is 1. R, which is the common ratio, is 3. 1 times 3 raised to the power n minus 1 is 3 raised to the power n minus 1. The nth term of another sequence is 4n squared plus n plus 3. Find the second term. To get the second term, we plug in n equals 2 into the formula, so we have 4 times 2 squared plus 2 plus 3, which is equal to 21. Find the value of n when the nth term is 498. To get n, we equate 4n squared plus n plus 3 to 498. When we move all the terms to one side of the equation and group like terms, this is what we get. To solve for n, we apply the quadratic formula and this is what we get. The number under the square root, 1 squared minus 4 times 4 times negative 495, gives us 7,921. For the denominator, 2 times 4 is 8. So for the first possible value of n, we get 11. And for the second possible value, we get negative 11.25. In this case, n cannot be negative and n cannot be a decimal, so n is 11. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.